Solids, page 4. The diagram shows a cone with base center O and radius 3. A is 5 centimeters vertically over O. T and P are on the circumference of the base, and O is the midpoint of PT. So that's a pretty good drawing of what I just read. It says to find AT, the slant height of the cone. So that would be this line here. They want us to find the length of that line. So you can see it's a right triangle, and we don't know the red part, but we do know that the height is 5, right? And we do know that the radius of the base is 3, so this is 3. So we can find the hypotenuse with Pythagorean theorem. It would be equal to the square root of 3 squared plus 5 squared, which would be 25 plus 9, 34. So it would be the square root of 34. Okay, so that's A. B, find the angle that AT makes with the base of the cone. So that would be this angle here, that angle right there. The base of the cone is, of course, that part here. Okay. So we could use almost any trig function here. How about if we just use tangent? Because so we'll call that angle theta, and we'll say that the tangent is the opposite over the adjacent, and so theta is equal to the inverse tangent of 5/3. Inverse tangent of 5/3 is 59 degrees. Okay. And that's B. C, find the angle PAT. PAT. So PAT is that angle there. Okay, so this is not a right triangle, but we do know a lot about this triangle. We know that the base is 6 wide, right? We know that the height is 5. We know the slant height is square root of 34. We know the angle here is 59 degrees. 59 degrees. By the way, 34 is, square root of 34 is 5.83. Okay, and so we want to know the angle here at the top. Actually, we can figure this out without using anything like law of cosines or whatever, right? Because you can see that the bottom two angles are both 59 degrees because it's a cone, right? So the top angle would have to be the angle PAT. The angle PAT would have to be equal to 180 degrees minus 59 degrees minus 59 degrees, right? Because the angles of a triangle add up to 180. So 180 minus 59 gives you 62. So the angle PAT would be 62 degrees. That's part C. Okay. 10E, number 1. Calculate the surface area of these solids. Okay, so let's see. First, it gives you an easy one. It says it's a 2 centimeter cube. So we just need to figure out the surface area of one side, and then all 6 sides of a cube are the same. So this surface area here would be 2 centimeters times 2 centimeters, right? It would equal 4. And it's got 6 sides on a cube, and they're all identical, so 4 times 6 is 24. Okay, that's the answer for A. What about B? Well, B, it's got different surfaces, right? But some of the surfaces are the same. So for example, the ends, look at these two ends. They're the same dimensions. So we could put 2 times because there's two of them, and the area is 2 meters times 1.5. Okay, and then let's see, we'll draw the top and the bottom in orange. So there's the top and the bottom, so there's two of those, so we could have 2 times, and the dimensions are 2.5 and 1.5, so we put 2.5 times 1.5. And then last of all, we got the front and the back. So the front and the back we'll color green. The front is green and the back is green. So we'll say 2 times, and it'll be 2 meters high and then 2.5 long. Okay, and so then we'll add those up. So 2 times 2 times 1.5 is 6. So the purple part is 6. The orange part, 2 times 2.5 times 1.5, 7.5. And the green part, 2 times 2 times 2.5 is 10. And the answer, 6 times 13.5, 23.5. That's the answer to B. Okay. C. ABCDF is a prism. CF is 5 centimeters, and triangle ABC is equilateral with sides 4. So this equilateral triangle here has sides 4 long. They're all 4. Okay? And we want to know the surface area of each of these, or all the sides put together, right? So like, let's figure out the surface area of the triangle. That's kind of the hardest one. Let's see, it would be 2 surfaces, and then the surface area of a triangle is 1/2 base times height. Okay? Now the base is easy, it's 4. What about the height? That's kind of hard because the height is not 4. The height would be this line right there. We could use Pythagorean Theorem to figure that out, right? Because we could draw that triangle here. It's got 2 on the bottom, we cut it in half, right? 4 here, and then the unknown here. So x squared plus 2 squared equals 4 squared. So x squared equals 4 squared minus 2 squared, which is 16 minus 4 is 12. So x is equal to the square root of 12. Okay, so I could put square root of 12 here because we already found the height. Okay, and then the sides, each one of these side surfaces is the exact same dimension because it's equilateral triangle. CF is 5. So each one of these orange sides is 4 times 5, and there's 3 of them. So 3 times 4 times 5. 3 times 4 times 5 is 60. So the orange part is 60. And the red part, let's see, square root of 12 times 4, 13.9. Oops. 13.9 plus 60 is 73.9. Okay, number 3. ABCD is a square-based right pyramid, and O is in the middle of the base. The side length of the base is 5 centimeters. 5. The height of the pyramid is 6. The dotted line is 6. Calculate the length of EM, where M is the midpoint of BC. BC. So BC is that, so the midpoint is like right there. If the midpoint is N, then EM is the length from the top of the pyramid to the middle of that base. So basically, we could draw a right triangle that looks like that. So it would be from the middle of the pyramid, O, to the midpoint of BC, M, and to E. And we're trying to find out this length here. We do know that the height is 6, and we do know that the side length is 5, and this is half the side length, so this would be 2.5, right? So we know that this is 2.5, and we know that this is 6, so we can easily figure this out because it's the hypotenuse. It would be square root of 2.5 squared plus 6 squared. 6 squared. So let's calculate that out. 2.5 squared, 6.25, plus 6 squared, which is 36. So, and the square root of that is 6.5. Okay? All right. And so that's the answer to A. B, calculate the area of the triangle CDE. CDE. So CDE is this triangle here. It's one side of the pyramid. So CDE looks like that. And the bottom of CDE is 5. And the height of, the slant height of CDE, we just found it at 6.5. 6.5. To find the area of this triangle, it's just 1/2 base times height. 1/2 times base, which is 5, times the height, which is 6.5. So that's equal to 6.5 times 5 times 0.5 is 16.25. What about C? Calculate the surface area of the pyramid. Well, all we need to do is to take this orange side, multiply it times 4, right? And then add the bottom surface area. And the bottom is easy because it's just 5 times 5, right? The width and height is 5. So 4 times 6.25, 16.25 is 65. And then I'm going to add the base, which is 25, and I got 90. Okay? And that was C. Last one, 5. Each side of a cube is 5.4 meters. Each edge of a cube is 5.4 meters. Calculate the surface area of the cube. Well, a cube has 6 identical sides, each one of which is 5.4 times 5.4, right? So the total surface area of the cube is going to be 5.4 times 5.4 times 6, which is 175. B. Give your answer to part A in the form A times 10 to the K, where A is between 1 and 10. They're basically saying put it in scientific notation. So that would be 1.75 times 10 squared. And just to make sure that that's right, we'll do 1.75 times 100. And you can do that in your calculator or otherwise. And that'll give you 175 just like you had before. So we just checked it with that. Okay? And that was page 4.